So the next thing on our agenda is that we have invited a number of supporters for this initiative and friends to talk a little bit about how they see, to give their opinion, their ideas about the vision and challenges of open virtual assistants. And to start off, we want to hear from Santander. Unfortunately, Michael Harte cannot make it, but we have Carrie, and who can talk to us about the vision. Thank you.
Hello, I'm from Michael Hart's team in Santander in the UK. We'd just like to share with you a few of our thoughts on Open Virtual Assistant, because we've been communicating, collaborating with Monica for a number of months now. I think for us, virtual assistants offer a significant opportunity for inclusion and engagement, because it very much puts warmth into the technology, human interaction and connection. I think people seem much more connected with technology when they're comfortable with the interface, and for the majority of people, voice is very clearly a way to do that. But I think we've begun to have drift towards a binary trade between convenience and privacy, which is very much hot on the agenda, because ultimately all of these things are all about data. And what we would like to see with more open approaches is the ability to have a more negotiated, equitable view of privacy and how our data is used as consumers, for our consumers and businesses. Because I think there's two key things here. And what this technology offers is the consumer wants a really personalised service. We all are individuals, and we want to feel unique, and we want to feel unique in how we engage. And that's what we at Santander would like for our customers. But then the privacy angle is absolutely key to us, because how our data is being used and what it's being used for is of paramount importance to people. And it's not binary. It depends on the circumstance. For me, as an individual, if it's a consumer good, I'm pretty open about what you want to do with my data, because, like most of us, it's about a good deal. But if it's something far more personalised, and Monica gave an example in her introduction, that's about my medical records or my health, that's a very much more closed conversation. And in order to achieve this big ambition, you absolutely need what Monica's just outlined in the last two slides. You need a very open collaboration. You need to create a network and an ecosystem that's not just about open technology, it's about open collaboration and open minds. Because for us, the goal of this work as well is to be able to put our customers back in control of their destiny, their data, and very topically, their voice. And so that's why we're really supportive of the work Monica and her team are doing. Thank you.
Next up, we are very happy to have Larry Hack. And you have a Samsung developer conference going on at the same time. And he's taking time to come and talk to us about his vision. And Larry is the CEO of the Samsung Viv Labs, and that means that it is the Viv Labs is the labs that brings us Bixby. And Larry has been involved in so many different companies working on so many projects. Maybe you can kind of tell them a little bit about where you come from and
I know many people around the room.
Yes, I know.
At different companies. So I'm going to show several clips of videos, and I'm not going to have time to go into a lot of details on each of them, but the videos are probably most important, because what I'm trying to show is what I'd like to see in the near future, not necessarily only working on the core technologies. We all need to do that and continue that. And I'm not saying that we should stop working on the core technologies, but I think we also need to be working on the higher levels, on the ecosystem part of the virtual assistants, to get them to scale. So of the three things that Monica talked about in terms of goals, we're definitely supportive of all three, especially the sharing piece. So you'll see the sharing part of this in the first video. So let me start the first video. This is kind of how I'd like to see things in the near future, at least the start of them.
Sorry, I don't know that.
Okay, Google, help me find my anniversary. Sorry, I don't know how to help with that yet. Hey Siri, help me find my anniversary.
Sorry, I can't do that.
Hi Bixby, can you help me plan my anniversary?
I'm not sure how to do that. Can you teach me?
Okay, so notice that I didn't show Bixby that we solved that problem. What I'm trying to show here is an unanticipated task. In this case, it's a higher level task where, in this case, we want to bring the user into this problem-solving mode that collaboratively between the assistant and the user will solve that problem. So there's a design philosophy that I think we should be following, which is always helpful. And always helpful is not just an aspiration that someday, we get all the core technologies problems solved, the systems will just always work, it's always perfect. I don't mean perfect. What I mean is that the systems will always provide some benefit, maybe getting you part of the way there towards your task, and then let you, with the assistant, complete the rest of the task. So saves you some time. So that's what I mean by always helpful. And of course, the best example of that is web search. I think that web search in the 90s, if it had a design principle that's similar to what we're doing with virtual assistants, which is you either get it perfectly or you just say, I'm sorry, I don't know how to do that. I don't think web search would have taken off like it is today. I think the reason it took off was even if you subtract away 20 years of relevance improvements to the search engines, it was still always helpful. It would get you part of the way there, and then there were other mechanisms to let you collaborate with the search engine, and it still is today, refining your queries and clicking through and that. So it's interesting that in the virtual assistant community, we've sort of gone away from that. I think we should come back to this kind of notion. So what would it look like in the virtual assistant space? Something, let's say the request is something like, hey, I'd like back row seats to Guardians of the Galaxy tomorrow at 7 p.m. Most systems a few years ago would have said, I have no idea what you're talking about because of the back row seats concept. Now, many of the systems will just ignore that you said back row seats and get you all the rest of it. So it'll do all the rest of it. And then if you then come back, yeah, but I want back row seats, and the systems will say, well, I don't know how to do that. I'm still learning, right? So imagine that staying within the conversation, within the assistant, you could actually complete that task where the assistant is watching what you're doing and helping you do it, but probably most importantly is learning how you actually completed that task and what that concept was, in this case of back row seats. So we facilitate learning by demonstration, and I think this is a major area of, obviously it's already a major area of research, but it's a major point of connection, I think, right now for personal assistants and that research community on learning by demonstration. So at the individual level, in addition to the systems learning implicitly from your interactions, with the assistant, we empower the end user to provide explicit feedback by saying, let me show you how to do this. Buy me back row seats to the theater. Okay, go to Fandango. Okay, there's the widget. Okay, I'm going to touch on the back row seats. Okay, remember that next time. Learn that concept. Now, for an individual, remember that it only has to work just for the individual. So there are certain ways that you're going to be saying things or referring to things, so the distributions can be relatively tight. But of course, we can think about sharing. This is the part about sharing. We can start thinking about sharing between the users such that you could benefit from, let's say, the effort that somebody else put into their assistant. So if I taught my assistant this concept of how to find back row seats, or let's say I want to check the grades for my son at Los Altos High, and I have to go through 7 steps to do that, there's a task that's been learned that I've taught my assistant about how to do that generalizes, let's say, to other schools. And let's say later, you don't know me, we're not associated, you're in a different part of the country, and or the world, and you want to, get back row seats, or you want to check the grades, and it just works for you, and you think, oh, must have been anticipated, inside of Bixby that I wanted to do that. But what was really occurring was that there was another user that actually showed by example. So we start setting up this sharing network effect, and obviously privacy is a huge deal here, very much playing to what Monica was talking about. We don't want to be, learning how to get access to your bank account and share that information. So the current approach to scaling within the different assistants is very much focusing on the developer. And so I was at Samsung Developer Conference yesterday, I gave a keynote, and I very much focused on, we still are, let's make it easier and easier for the developer to build out these kind of capabilities. And so I think that's right. That's definitely the right path, but I think we need to go further if we really want to scale up the number of skills that we're talking about. We need to involve the user and the user community as part of the development of this AI. So that there's a number of technical challenges that's associated with that we have to solve if we're going to do that, so that we're effectively sort of crowdsourcing this AI skill level. So how do we start this? So let me play another little video clip to show what it might look like.
Hey, Bixby, help me find an anniversary gift for my parents.
How about flowers?
Nah, traditional one.
I'm not sure what a traditional gift does. Can you show me?
Go on Wikipedia, search traditional wedding anniversary gift.
I found wedding anniversary on Wikipedia.
Okay, scroll down. Scroll down. There.
Okay, I'll remember that. Since it's your parents' 30th anniversary, how about a gift of pearl earrings and mother-of-pearl cufflinks?
Perfect.
Here's a selection of earrings and cufflinks.
Start.
Bixby learns new capsules from everyday interactions with millions of users on every kind of device. From Family Hub to all of Samsung's products, Bixby brings the multi-device experience to life.
By the way, at the very beginning I showed, the system not knowing about wedding anniversary, and so each one of these clips is different aspects that different people are teaching. So I'll show a few more, and then at the end we'll put it together. But this notion of reading tables and understanding semantically, Alon's here. I mean, there's been a lot of work in the search community, web search community, for a lot of years on this problem to be able to make that kind of structured or semi-structured information discoverable from search engines. And so there's a lot that can be leveraged there and plugged in. This for personal assistance, this idea that you can show the assistant, hey, this is what I mean, this is the content, in this case the definition of wedding anniversary gifts per year. I want you to know that, and then, okay, now I want to be able to talk to you about that and help me complete the task given that you got this new information. The same thing, there's many sources of structured information out there, and I know Sujit's been doing a lot of work on this as well at Google, and Dilek and I have done a lot of work on this. A lot of things to be leveraged. Forms is another example, all the way out to computer vision. There's a lot of structure in the computer vision or grounding that you can use, particularly with the advances in the computer vision algorithms these days. And then all of that connecting into a knowledge graph representation. We call it a conversational knowledge graph. It's essentially an extension of a knowledge graph with mining for conversational relations between entities. So on the computer vision side, I think that, so the video just showed, tables, and I think you get the forms. Let me show you what I mean by, or what this might look like with computer vision.
Hi, Bixby. Help me find a vase that matches these.
I think these are crystal candlesticks, but I need more information. Can you tell me the brand?
They're made by Waterford.
Okay, I found several Waterford vases. Here is the Lismore 8-inch vase.
Is there a larger one?
Okay, here is the Lismore 14-inch vase.
That's perfect. Show it filled with flowers. Andrea prefers white roses. Nice. Where can I buy it?
The Waterford Lismore 14-inch vase is available with 2-day shipping for $495 from Neiman Marcus.
Add it to my cart.
Bixby combines voice and vision to make both work better. Bixby is always helpful and always learning.
So in every one of those clips so far, you've seen there's actually a fail. The assistant did not know how to complete the task, and right now it would just bail. But you've seen that we're leveraging a combination of different technologies to allow the user with the machine, with the assistant, to complete the task. So there's a lot of key challenges. I'm just listing 5 here. But when you have something like that where you're trying to leverage the structure and the grounding that the user sees when they're interacting with it, of course, one of the first tasks that you have to, or one of the first technical challenges you have to deal with is how do you learn by this task demonstration? So if I show you on an app a sequence of steps, or I point you to a table, or how do you actually do that and learn that kind of information? So the second one is learn the interface to the service backend. So if there is, as Monica was talking about, a query kind of language that you've gone from NL to the query language, or you've programmed it more directly to back in the app side for, let's say, app indexing kind of accesses into backends, you still need to be able to learn that connection. And then the third is, once you have that, you learn by demonstration and you have this backend connection, and you have the structure, can the system automatically induce this conversational interface to that structured content? And there's been a lot of work done on that over the last 5, 6, 7 years. The fourth is interoperability. You need to be able to, first of all, cluster. Let's say we're getting contributions from all these different users and developers of different AI skills or capsules. You have to be able to identify that, oh, these are the same kinds of things. We can generalize. These are distinct. Some of these things you have to recognize, which you'll see in a couple of minutes on the video, that you need to compose together so that you can actually complete this broader level task. So this interoperability between these AI skills or capsules is super important. And then finally, if all this works, we've created another problem, which is we have way too many skills to deal with. The user starts to interact with their assistant, and how does the system find that there's actually something already there that some user produced? So we'll talk about that, but I'm just going to talk about that a little bit. I mean, effectively, that puts us back into a search paradigm. So I'm mainly just going to talk about these 3 right here. So there's been a lot of work done on programming by example or program synthesis, and so the purpose of this slide is just to make that connection, to point to that. A lot of great work, especially at Microsoft in this area. This notion that programming by example is more of a learning of the logical steps. It's complementary to machine learned methods in the sense that you don't need a tremendous amount of data to be able to learn those kind of concepts, but it's complementary because you certainly want to be able to refine what you're doing with data after you get that kind of those construct of the task. And the combination of work that's being done by developers and data that you get, that you're learning, that is kind of a hybrid model, this idea of logic plus data. And like I said, Sumit has done a lot of work on this over the years at Microsoft. It's actually in products like Microsoft Excel, at least the programming by example side. What he's working on now and what I'm inspired by is this combination. So this is just a sampling of work that's been done on this space. There's lots of other work. Alon's work, and that's continued. Sumit's work I just referring to. There's a lot of work right now at CMU, PhD student there that's working on building conversational bots for mobile apps, and then how to actually learn this kind of task from demonstration. And then at Samsung Research America, Bixby, in my team there, we've been doing a lot of work on this recently as well. So the third step on this is automatically inducing a conversational interface. And so let's say you had a form, this idea that you have many forms and you can organize these forms by these domains. And it's pretty intuitive that, if you know Southwest Airlines, your assistant knows Southwest Airlines and is able to drive a dialogue over that form, and you have British Airlines, that if you go to KLM, that you shouldn't have to start from scratch. You ought to be able to leverage that information at all levels. There's the form itself, but all the way up to the natural language understanding and the dialogue. You ought to be able to borrow that. And so we did a lot of work on this at Google and showed that not surprisingly, going down the columns here, you can borrow a lot. You don't need much data at all once you have a few of examples from the domains, the verticals. But the surprising part was that there was a lot of benefit by going horizontally across these domains. And it turned out that we started to believe actually there's some finite set, kind of like what Monica was referring to, this finite number, relatively small number of these examples and these different domains, that if you learn that space, you pretty much have it. You need a little bit of data outside of those core things that you learn, maybe, hundreds, not that many. But it greatly simplifies the task for the developer or the end user eventually. A lot of work that's been done at Microsoft Research and Google Research, and these are the places I've been. So I've been working on this for a while with Dillick and others. This is where all of the different people that don't know each other have contributed to components or different pieces. Those pieces have been composed together. And now what I'm going to show you is the same query that we had at the beginning, but this one other user benefiting from everybody else.
Hi, Bixby. Can you help me plan my anniversary?
Sure. Since it's your 15th anniversary together, would you like to see some options you and Olivia might like on the living room TV?
Yes.
Let's see favorite getaways.
Capsules created by millions of individuals are searched, combined, and composed to make Jack and Olivia's anniversary the best ever. When Bixby learns from many users, powerful network effects benefit every user across all our products. By empowering our users to create their own personalized AI experience, we build user engagement and loyalty, enrich our platform with data, and enable Bixby to become exponentially smarter.
Now, of course, that could be the Oval platform. It doesn't have to be the Bixby platform. So let me just say a couple words about the search problem. One of the things that I think is going to happen if we're successful here is that there's going to be a new emphasis on search. But in this case, rather than just going from data to information, we're going to the next level, which is information to the AI skills, which sits on top of and is a superset of web search as we think of it today. And I think a lot of the same kinds of techniques and approaches can be used. There are also the same kind of monetization opportunities, if you think about it, get built. So it's the difference, though, is that instead of it being a two-way person to search engine with a browser, it's a three-way conversation because you're talking to your personal assistant. The personal assistant is searching for you and then guiding you through dialogue to what you need. And the personal assistant remembers what you did and learns from that from every interaction. Okay, so where are we today on this scale vision? We are focusing very much on the third party, the developers, the 3P. It takes relatively high skill for a third party developer to build these AI skills or capsules. What we're trying to do is drive down that level of expertise while maintaining the quality of these skills. And so our strategy is to get to what I'm talking about to the users. We go through the developers. We basically cut our teeth on developers, make our developer experience just easier and easier and easier until the point where power users can start to do this. It's so easy. And eventually we can get this out in situ, in dialogue as well. And then ultimately we have capsules or AI skills writing other capsules because in some situations we don't even need to have the interaction. So that's it. Thanks very much.
But some of these skills involve just learning language. So for example, when you say back row seats for the show, that's a language. If the system will understand the language, it could assemble the action easily. So some of this learning is skills, but some of it is just language. And
Yeah.
how do you decide where?
Yeah, exactly. The skill couldn't be completed because of the one language concept. And I would say that most failures are happening because of this. It's not so much that the task wasn't described properly or the skill. It's just that there's a new parameter that wasn't anticipated. And so the reason I put that in there is I'm trying to show that this level of collaboration with the user can be used to learn at that base level, these new concepts, slots, all the way up to composing these things together and learning, tasks.
Next, we have Jayesh Govindarajan from Salesforce, and we've been chatting for many months about this initiative, and I have to say that Jayesh is the reason. He's the one who encourages us to get this workshop going, even though we are very, very late in the preparation. We didn't have enough time for preparation. Well, thank you.
Thank you. I want to talk a little bit about a slightly different point of view on these conversational systems. And this is the point of view that comes from sort of working on the enterprise side, less on the in-home assistant side. And as you can tell, the kinds of conversations we hear and track are quite different from what one might be talking about with their in-home assistants. Specifically, the structure of the conversation, the length of the conversation, the complexity of calls that you make to your internet service provider, for example, the fact that it's not something that is entertaining. People don't really want to talk to their ISP for getting a problem fixed, but do so anyway, want to get answers quickly. These are sort of areas where they're different, but there's lots of similarities to, I think, what we're seeing in the rest of the evolution of virtual assistants as well. So on the Salesforce platform, most customer service conversations, this massive scale, of course, about 16 million conversations a day. And there's a canonical structure to these conversations. At a high level, there's an opening, there's a body of work that happens as humans interact to solve a problem, and then there's a closing element to it. We study this because we want to be able to design fully automated agents for scenarios that can be fully automated and assistive agents that can assist the workforce in the whole resolution sort of workflow. In the customer agent conversations, there is further structure that we see. For example, this is a canonical structure that we see in a lot of retail scenarios. There's a greeting, there's a confirmation of intent by an agent. There's a step where there's a back and forth to do with the collection of data. There's a resolution that emerges, and there's a back and forth on the resolution, and there's a closing as well. And this is sort of completely derived from data. And going back to, I think, what Larry was saying, as well as Monica, I think there is a structural element to this that sort of cuts across scenarios. You can bet that there is a similar structure that emerges in great sales conversations, for example. And the key takeaway is that these are topic agnostic. So you might be talking about getting information about an order, or you might be talking about returning an item, or you might be having a conversation with a mortgage agent about getting a new rate for your home loan, and these all sort of go through a structure which is similar to this. And this is no surprise because well-trained agents follow this structure to get and guide to a resolution, right? So that's about the structure, and there's a sort of archetype of structures as well. There's about, I wouldn't say 100 in the enterprise space, much lesser actually, we believe. And the next thing that we looked at in addition to structure is sort of the topics of conversation and what that looks like. This is probably a bit of an eye chart, but essentially what this is us trying to figure out what are the top types of conversations across industries, going back to what Larry was saying. So if you look at retail, consumer goods, cable ISP, banking, insurance, these are sort of 5 top industries that Salesforce operates in. We have access to these conversations. There's always like a top 3 that emerges, which accounts for about 60% of the conversational traffic. In retail, it wouldn't surprise you to know that checking your order status or returning an item are the 2 top ones. There's similar examples in consumer goods, cable and ISP, in banking and insurance. And the takeaway, again, is that these are agnostic of the structure. So if you follow the structure of conversations that I talked about earlier, you can change topics, but be able to get to a successful outcome regardless. And this is great news for designing virtual assistants, obviously. Now I'm going to go into the details here, but skip through this a little bit. Basically shows there's a long tail. If you solve the top 3 scenarios, you're in good shape. Okay, so what we've learned is that across topics as well, there is sort of 3 main areas that emerge in terms of what these conversations look like. One is sort of informational, the other one's conformational, and the third one's transactional. And this is, of course, important in designing, agents as we want an agent to be able to do all 3 well. Informational, fairly straightforward, sort of where's my order, what's the monthly payment for this basic policy, really doesn't need a transaction to be executed. There's information in the back end, and you want your virtual assistant to be able to answer that question effectively. The second one's conformational. This is more like a lookup in that, are you eligible for an upgrade? Has that order been shipped? These are also simpler ones, but we see this coming off a lot where users have something they're expecting and they need to actually talk to a system to be able to do it. Completely automatable. The third one, which is the tougher one, is the transactional bit. This is, a lot of the examples and videos that Larry showed and Monica talks about are, fall under transactional. And I think this is where there's a lot more work to be done in terms of building systems, task-oriented systems that each of us are sort of trying to build in the full stack. And this is sort of the point of my talk here, is that if you break open any of the systems that are in production today, be it Amazon's Alexa or Google's, Salesforce's own bots framework, Bixby as well, there's sort of the question answering problem, which solves the informational, conformational type of scenarios, and a task-oriented dialogue sort of system problem, which solves the transactional one. And the big takeaway is that there's structure and topics across this, but these are 3 big areas that if we solved, I think we'd be in pretty good shape. Monica said that we should talk a little bit about challenges. I think the big challenge I see is to Larry's point, is the ecosystem. I think the fact that every single company is building this is a problem for the ecosystem. And that problem is that if you're a developer, you're going to have to build one each and be deeply tied to a system if you want to do a good job of building a task-specific virtual system. For the platforms, this ends up being a bit of a zero-sum game, right? I think for those of us that were around when Java kind of got started, this goes back to sort of write once, run anywhere assistance. We are far from it, and this is probably the reason why the ecosystem hasn't really taken off. And I'm not talking about the 1,000-odd simple skills that are being put out there. I'm talking about like sophisticated systems that work. The reason it's not out there is because it's expensive to build one, and then it's tied to one domain. So I think that's a problem which we will see eventually roll out if we don't solve this problem. And I think the third thing that both Monica and I think Larry you referred to as well is that there is a need to unbundle these elements, right? Because this is sort of a monolith. We have device capability, which is the very lowest layer. In our case, those translate into APIs that we build on top of. From a developer's perspective, it's a skill that they're producing in the form of an API. And everything on top is being able to compose that into higher order tasks, and then a front end, which is essentially a conversational front end. These are sort of kind of a layered cake, if you will. And I think the big takeaway for me is, at least, and the reason we need to sort of align on this, is that there's areas of collaboration that we need to unlock so that this ecosystem can be built and thrive. In the interest of time, I think I'm going to stop, but I'm open to questions as well.
So good news is I don't have slides. Bad news is I can still talk, right? So I thought, I was thinking about comments that would be relevant for sort of this forum, for the Oval workshop, what we think we can get out of it and what kinds of problems might be useful to address through this forum. The first question, when I had a chat with Monica a few days ago, she asked was, why is this a good thing for a place like Amazon, or why would we support it? And I go back to things like Kaldi or Stanford Core NLP things, or even going further back to CMU's Sphinx and Janus things. I think it's important to have, even if it's not deployable strength, industrial grade, state-of-the-art platforms in academia, so that the research that's being done on these platforms is also state-of-the-art, and it's advancing the state-of-the-art. And then the PhDs come out, those who go into academia are also at the leading edge, but those who come to industry, which, as you know, vast majority of PhDs, it's not like the social sciences or the arts where a PhD is a path to an academic career. Most PhDs come to industry. They come ready to contribute. So I'm very hopeful that this will create, as conversational AI as a field has been evolving as a field, we've had speech recognition, you've had NLP, you've had machine translation, you've had these component technologies. There is a science emerging that we'd like to see come to fruition as a field of conversational AI. The phrase has come. The general science in that field, it would be good to see it develop out, and I think that's the contribution that Oval can make, and that's why we are in support of this initiative. God knows if we had 100 scientists standing here right now, we'd interview right now and make at least 40 offers, right? So there's no dearth of opportunity for talent that will come out of these initiatives. In terms of the problem space, these AIs, as we like to call them colloquially, are super useful in the home today, but they're not so far up the AI stack. If we think about the AI stack with starting from phenomena modeling, or moving next to some kind of intelligent decisions, moving next to reasoning, and then autonomy. And then I tend to think of automated general intelligence as sort of beyond top of stack. It's a stack that I don't find practically inspiring or useful to me for my lifetime or my kids' lifetimes, right? But within that movement, I think we've made the transition from the phenomena modeling, which I think of as the sensors are picking. Of course, there's a sensor layer, but sensors are picking up speech, or you're getting in text, and you're inferring some things from them. And then we've gone up to the stage of intelligent decisions. But getting to the step of reasoning, a common paradigm is, I think of as search. We do search in a particular way in the browser world. We don't know what it looks like in other kinds of interfaces. Even experiences like shopping. There's the opportunity to actually interact with the user in a way gives you an opportunity to exercise your reasoning about certain things. And what do we reason over? We reason over context, right? What's the personal context of the user? What's the world context? So I think as these AIs are to become more capable, one area I find interesting is how do we bring in more and more context, whether it's personal context, the ambient context of the user, or the world context and what's happening in the world, and how do you better do things. A second thing I find interesting is, or will be super useful, is continuous learning. We build, we deploy, but we'd like these systems to sort of, at least as a lower end of our aspirational scale, maintain their performance post-deployment. Being able to do more things post-deployment and learn new things post-deployment would be awesome, and that's a very sort of noble science goal, and one that we're also interested in. But just maintaining it so that you don't degrade from the day you deploy is an important thing. So a simple example of what we've deployed and that my colleague Ruhi Sarika's team has deployed is this thing called feedback-based learning that operates at the front end of the system. So it does corrections automatically with no human in the loop. So if you say, Alexa, play SiriusXM Chill, and Alexa doesn't know what chill is, you'll have a frictionful experience because she won't respond. She says, I don't know how to respond to that request. If 100 people say that, 95 of us may walk away, but 5 of us are like my youngest daughter. They keep trying, right? And so what happens is there's enough signal there to learn and say, the 5 of them, maybe 4 of them said, Alexa, play SiriusXM channel 53. You can observe over time, and when you can aggregate over data, this is a little bit of a peek into reasoning. It's not like really the exciting reasoning, but a little bit of a peek. You now learn, you automatically learn an equivalence class. That SiriusXM Chill is channel 53. You can also learn other corrections, like send me Lauper is play Cindy Lauper. It just happens to be a very common kind of error that happens, and so you can do that too. So at the front end, you can fix some of this frictionful experiences for the user and make that experience better very rapidly. We can do this sometimes within hours, often within a day. We fix all of these friction. But what would be interesting is how do we bring back some of those concepts further up the chain? Because once I've learned that chill is the same as channel 53, I'd like to be able to answer questions in a completely different domain. I don't want just to know that this question is equivalent to this question. It'd be good to know this concept is equivalent to this concept, but then to be able to reuse that concept in a different context. Like if I say, who's the founder of SiriusXM Chill? That's a completely different kind of domain and context. We'd like to be able to answer that question without, again, having to rely on saying, I don't know, and then somebody else then says, hey, who's the founder of SiriusXM channel 53? So there are problems like this where you can detect behavior-based signals at the very tip. You can fix the friction at the very tip, but then how do you bring that stuff back all the way up to the chain? So I think that's super interesting. There's always a lot of talk of reinforcement learning. It'd be good to see a deployable version of something that actually does something for users. So I would say that should be a grand challenge task for Oval. Certainly if students and faculty at Stanford can't do it, there is a reason to not be optimistic about it. So I would say that's something to look at. There are limited areas in which reinforcement learning works, but the big notion that we can learn to do new things through reinforcement learning by involving the user would be good to look at. There's a bunch of other things, how to expand the conceptual space that these conversational AIs operate in without requiring the kind of annotate, train, and deploy approach we have. Unsupervised learning, not just as a way of improving the performance within the space we operate in, but expanding the space that we operate in, et cetera, would be interesting. So with that, I look forward to coming back next year and seeing all the awesome work that the students who are involved with this lab are going to talk about. Thank you.